Hi everyone, welcome to another video mechanics, and in the question we're going to have a look at today, it says that there is a particle. They give us a particle in equilibrium at O, so that's our very weird axis. Still a bit weird, that's better, and that's O, and we have a particle there at O here, and it says that it's under forces Pn and Qn. So P newtons and Q newtons, those are two forces, and then a third force which is Xi and Yi. So we've got one force which is P newtons, the other one which is a force of Q newtons, and then another one which is Xi, where I is the unit vector in the X direction. This is the X direction and that's the Y direction, and plus Yj. It's not a normal J. Newtons, right? So these are the three forces acting on the particle, and it says that it's in equilibrium, so super important, in equilibrium, and they ask us to find X and Y, find those two guys if they're in equilibrium, and they give us in the question P and Q. So they tell us that P is 2I plus 3J, and they tell us that Q is 3I plus 5J, right? And that's it. So they give us P, they give us Q, and they ask us for this third equation here, this third force here, if that is to be in equilibrium. So just to make a rough diagram, this we're going to solve in a different way from the normal angles and all of that, but just to make a rough diagram, P is 2 and 3 both positive, so P would look something like this, 2 in that direction and 3 in that direction. So it would look like that, where that was 3 and that was 2. And Q was 3 and 5, so Q would be 3 in that direction and 5 in this direction, 5. So something like that, and they're both positive. So this would be our Q that they give us, and this would be the P. And they're giving it, and they tell us that given these two forces, there needs to be another force which is this one, Xi and Yj, which is going to be able to cancel all of those so that the particle is in equilibrium and the overall force is 0. So I'm guessing it's going to be a force that goes along here somewhere, right? And it's going to have to be pretty big to cancel them both, and it's going to have to come right here. So probably X and Y will come out to be negative, because the X component and the Y components are going to have to be down and left. This would be X and this would be Y, the magnitude. So they're asking us for how big that has to be, and this has to be, in order for this Q and P to be cancelled and the particle to stay there in equilibrium, right? So they give us this and they give us that, and they ask us for this. So let's see how that works. We know that it's in equilibrium, so basically that means with these questions, when you have it in I's and J's, you don't have to get involved with the angle so much, and you can just say, okay, if the particle, that's a lazy way of writing particle, is in equilibrium, lazy equilibrium, then the overall component, so the overall vector components in the X direction have to be equal to 0. So the overall coefficient, you can say the word is coefficient of I, coefficient of the direction I, have to cancel, and therefore they add up to 0. Same argument is true for J coefficients. So having said all of that, we can go up here and say that let's add up all the I's and all the J's. So when we add up all the vectors, the other way we can do it is just to add up all of the vectors straight off. So then we would have P plus q plus the mystery vector we're going to call r, they have to equal 0, both in the I and in the j. So then we know that 2i, this is plus 3j. Make sure you underline this, which is p, plus q, which is 3i plus 5j, 3i plus 5j, and then finally plus the x and y plus xi plus yj. That all of that has to equal to 0, right? And hopefully that makes sense. The x and the y, because I've added everything together as if it was positive. If x and y are negative, then it will come out of the work calculations here that x and y are negative, and we're expecting them to be negative because they need to cancel these two vectors, guys. So let me delete this just to open a little bit more space. Then we're saying that let's do the i's first. So we do the i's components first, because we can do them individually. That's what's great about i's and j's, and or x's and or y's, and anything that's perpendicular we can split it up and look at it individually. So let's do the i's. Resolving, also equating the i's, we have 2 here plus 3 plus x i's is equal to 0. So then 2 plus 3 is 5, and 5 plus x is equal to 0, so we subtract 5 from both sides, and we get that x is equal to minus 5. So that's in concordance with, in agreement with our diagram here. This is minus 5, makes sense, that's in that direction, and we expect y also to be negative if our diagram is correct. And j is here going to be 3 plus 5 plus the y equal to 0. So this is nice and easy, and 8 plus y is equal to 0, so our y is minus 8, and again it makes sense that it's minus 8 because it needs to go down, and 8 is quite a large number here compared with the sizes of the others, which makes sense because this vector is going to be pretty big to cancel with both of these p and q. Okay, so hopefully that makes sense. And so basically what we've said is that the coefficients of I and j both have to be 0, and in fact the full vector has to be 0, so we can just say that all of the vectors added together have to equal to 0, and since they are generous and they give it to us in terms of i's and j's, we can just add them like that. That was p, that was q, and this was r, and we can equate i's, you add all the i's and you make them equal to 0. All those i's, make them equal to 0, and then you add the j's and you make them equal to 0, and you get your answers for x and y. Right, so our full vector at the end would be 5 and minus 5 and minus 8, so our vector r then in full expression would be minus 5 times I minus 8 times j. That would be our full vector, which manages to cancel all of that, all of these two, to get a particle in equilibrium who doesn't move at the center. I hope that helps. The other questions in the exercise are pretty similar, and I won't do more examples because they will make everything else more easy, and I want you to practice a little bit. So just use these ideas to solve for the others, and hopefully they'll go okay. Alright, so hope you enjoyed that, and see you in the next video.